In large engineering organizations, security requirements don't exist in isolation. They span multiple teams, systems, and compliance frameworks such as ISO 26262, DO 178C, IEC 62443, and FDA design controls. But today, the workflow for engineers is fragmented. To understand a requirement, an engineer leaves the IDE, searches in Jama, interprets the requirement, returns to code, and later, often manually, creates trace links. In practice, traceability is incomplete, requirements drift from implementation, and during audits, teams struggle to prove that what was built matches what was specified. This gap between implementation and documentation is one of the most common audit findings. The Jama Connect MCP closes that gap by bringing governed requirements, traceability, and auditability directly into the engineering workflow. Approved, reviewed, and version-controlled requirements in Jama can now flow directly into modern AI-assisted development cycles. From Jama Connect through MCP into the IDE, where engineers and AI coding assistants like Codex or Claude can use that context to generate implementation and tests. And critically, the flow doesn't stop there. Code, tests, and validation results can be traced back into Jama Connect, creating a continuous governed loop from definition to verification. In this example, we're looking at a platform security team implementing secure service-to-service authentication across a distributed system. In practice, this pattern applies across dozens of teams, hundreds of services, and tens of thousands of requirements, but we'll focus on a single implementation to illustrate the workflow. From within the IDE, the engineer retrieves the requirement and its full context. This includes requirement definition, metadata and governance state, and relationships to upstream system, safety, and regulatory requirements. In this case, the requirement traces upstream to a cybersecurity control aligned with IEC 62443. This ensures that what is being implemented can be directly tied to regulatory intent, something auditors expect, but teams often struggle to demonstrate. As implementation begins, gaps emerge. The requirement defines mutual TLS, but does not specify certificate validation rules, identity extraction, or authorization enforcement logic. If left unresolved, this creates ambiguity and risk. The engineer updates the requirement directly from the IDE. This is not an informal change. It is governed by Jama permissions, reviewed and version controlled, and recorded in audit logs. The refined requirement now becomes a trusted input, not only for the engineer, but also for AI-assisted development tools generating implementation and test logic. With the requirement aligned, the engineer completes the implementation. The updated requirement directly informs the code being written, ensuring alignment between specification and behavior. The engineer embeds a reference to the requirement in the code and creates a formal trace relationship. While we're showing a single service here, this pattern scales across hundreds of services and thousands of requirements, creating consistent system-wide traceability. This is where traceability delivers operational value. Using Jama Connect's traceability information model, teams can analyze not just direct links, but structured relationships across upstream regulatory and system requirements, downstream software components, and associated verification artifacts. If this requirement changes, for example, a new certificate standard is introduced, teams can immediately identify all impacted areas. This supports formal change impact analysis workflows required by standards like ISO 26262 and FDA design controls, turning traceability into an actionable system, not just documentation. Teams can validate traceability completeness across the code base. At scale, this supports coverage analysis across requirements and implementation, verification alignment between code and tests, and continuous audit readiness across the product lifecycle. With Jama Connect MCP, organizations can integrate governed, approved requirements directly into AI-assisted development workflows, ensure traceability is created as work happens, not reconstructed later, and maintain continuous alignment between requirements, code, and verification. The result is reduced audit findings, faster and more reliable change impact analysis, and fewer defects caused by requirement gaps. This is how large engineering organizations scale secure, compliant product development while enabling modern development practices.